Welcome to myprojectbazaar.com. Now I am going to discuss about title for this project. Our project title is Contrast Enhancement by Nonlinear Diffusion Filtering. Now I am going to discuss about abstract for this project. Our abstract is the utility of the contrast enhancement is broadly familiar from the photography, particularly the digital photography, in which it is employed to help the compensate for the physical illumination of the photographic equipment in comparison to the capacities of the human visual system. Intrinsic image component can be regarded as a set of images, description and image in terms of scan, illumination, shape and reflectance of the surface in the screen. Decomposing an image into its intrinsic component have a wide range of application in industry. To solve this intrinsic decomposition problem, it is necessary to obtaining a prior knowledge on reflectance and the shading. Intrusion image decomposition aims to separating an image into a reflectance and the illuminance layer. The illuminant values represented the amount of reached light. The proposed system, which performing the Split Bergman's algorithm for the intrinsic decomposition and adjusts the illuminance layer of the proposed image to avoid the potential color artifact introduced by the illuminant adjustment and reducing the computing complexity. The proposing the decomposition model is performed on the values of channel in the HSV space, and the performance of the proposed system is evaluated by using the obtaining the results with the conventional decomposition methods. Now I am going to discuss about block diagram and the flow diagram for this project. First one is on a flow diagram. In that block diagram, first the block is an input image acquisition module. Here we getting on one input image from the dataset folder. After we getting the input image, the image values goes to the image pre-processing stage. The aim of the pre-processing is an improvement of the image data that surprising unveiling the distortion of UI get function is to get an image from the dataset. After getting the input, the pre-processing steps has been performed. In that input image is resized into a 256 x 250 sized image for the pre-processing. Likewise, all the images in the dataset was pre-processed. The pre-process will have some noises which should be removed for the future process of the image. The image noising is the most appropriate, such as shadow regions and the underexposed region. In this process, we are using the image pre-processing of the channel separation and RGB to HSV conversion. In the channel separation module goes to the intrinsic decomposition method. The intrinsic image decompositions aim to decomposing one image into a reflectance and the illuminance layer. As it is highly well posted, we propose to introducing the intrinsic decomposition prior as our constraint included. First one is a neighboring pixel with the similar colors should have the same reflectance. Neighbor pixels have similar illuminations. Therefore, we formatting the intrinsic decomposition problem as a minimization problem of the energy function. The first and the second terms of regularized on the reflectance and the illuminance layers respectively. The goal of the reflectance is correcting to the improving the uneven illuminant of the image caused by sensor defects, non-uniform illumination of the scenes or orientation of the object surface. After computing the reflectance and the illumination layer, the following task is adjusts the illuminance values in enhancement image. Details presents the widely used mapping function, including log, sigmoid and the gamma function. It can be observed that these functions all the lightening dark areas while preserving their lightness order. Since the mapping function is intended for enhancing the global contrast, we further adapting the CLAHE to improving their local contrast enhancement. Finally, we calculating the performance evaluation. Take signal to noise ratio after abbreviated PSNR. In terms of the ratio between the maximum possible power of the signal and the power of corrupting the noise that affects the fidelity of its representation. The structural similarity SSIM index is a method for predicting the preserving the quality of digital television and the cinematic pictures as well as other kinds of digital images and videos. The MSA is a measurement of the quality of estimator. It is always non-negativity and values closer to zeros or better. The MSA is the second moment about the original of the error and thus the incorporates both the variation of the estimator and its bias. Now I am going to discuss about flow diagram for this process. This is our flow of a process. First one is an input image acquisition model. Here we are getting one input image from the dataset folder. After we are getting the image will go to the image pre-processing stage. In the pre-processing stage we have two steps. First one is a channel separation. So here RGB channels are separated. Next one is an RGB to HSV conversion. So RGB images is converted into huge saturation intensity images. Next one is an intrinsic decomposition. The intrinsic decomposition and the illumination adjustment are done here, and the gamma mapping is used for the illumination adjustment. After finishing the illumination adjustment, we have getting an image enhancement. In that image enhancement, we are using a HSV to RGB conversion after CLA HE model. And then after the image enhancement, we comparing the original image and the enhancement image by using PSNR, MSC, SSIM and correlation calculation. Now I am going to discuss about output for this process. In this process, we developed in MATLAB 2017 B version. Go to the current folder and select main.m file. Right click the main file and click run button for run the process. Now I am going to select image.10.jpg image. Now I am selected. The process is going on. So first one is an input image. Next one is an resized image. After the resizing, we get HSV converted image. Channel separation is displayed here. The view channel is displayed. Next one is an intrinsic decomposition method. This is a reflectance layer. This is illumination layer. Illumination adjustment image and integrated image. This is enhancement for gray image and RGB enhancement image. Now we are comparing the input and the contrast enhancement, and the performance measure is evaluated and displayed here. The PSNR is 58 and the SSIM is 0.0075. Now I am going to run the another image. Now I am select image 15.jpg. So in that image have 57.9446 PSNR value. The input and the contrast enhancement of the image is displayed here. Thank you for listening. Our demo is completed. Thank you.